Right now, at this very moment, over 4,000 radio telescopes across Earth are listening, scanning, searching. They've been doing this for over 60 years, combing through millions of signals from space, and the silence is absolutely deafening. You see, if aliens exist anywhere in our galaxy, we should have found them by now. The math is crystal clear. Our Milky Way contains over 400 billion stars. Conservative estimates suggest billions of potentially habitable planets. Even if intelligent life emerges on just 1 in a billion worlds, there should be hundreds of alien civilizations in our galaxy alone. Any civilization just 100 years more advanced than us would be broadcasting radio signals we could easily detect. Signals that would stand out like a lighthouse in the cosmic darkness. But here's what's keeping scientists awake at night. We've found nothing. Not a single confirmed artificial signal. Not one piece of undeniable evidence that we're not alone. This is the Fermi paradox, and it's one of the most disturbing mysteries in all of science. The numbers should guarantee that aliens exist. Drake's equation, formulated by astronomer Frank Drake in 1961, attempts to calculate the number of communicating civilizations in our galaxy. Even using the most conservative estimates, the result suggests thousands of alien civilizations should be detectable right now. The galaxy is 13.6 billion years old. Earth formed just 4.5 billion years ago. That means alien civilizations could have had a 9 billion year head start on us. 9 billion years. Imagine where human technology will be in just 1,000 years. Now, multiply that advancement by 9 million. Any civilization with that much time should be obvious, unavoidable, impossible to miss. They should have radio signatures, megastructures, obvious signs of engineering on astronomical scales. But when we look up at the night sky, we see nothing but natural phenomena. In 1977, astronomer Jerry Emmon was analyzing radio telescope data when he discovered something that shouldn't exist. A powerful, focused radio signal lasting exactly 72 seconds, coming from the direction of the constellation Sagittarius. The signal was so strong, so clearly artificial, that Emmon circled it on the printout and wrote "Wow" in the margin. The WOW signal remains the strongest candidate for extraterrestrial communication ever detected. But here's the problem. We've never detected it again. Despite decades of focused observation of that exact region of space, the signal never returned. Was it a one-time message, a technological accident, or something far more mysterious? The WOW signal haunts SETI researchers because it represents everything they're looking for, yet provides no answers. But the WOW signal is just the beginning. In 2007, astronomers detected the first fast radio burst, a powerful pulse of radio energy that lasted just milliseconds, but released more energy than our sun produces in an entire day. These bursts come from deep space, billions of light years away, and their source remains completely unknown. What natural phenomenon could produce such intense energy in such a brief moment? Some scientists propose neutron star collisions or black hole formations. Others suggest more exotic explanations. But a small group of researchers has proposed something far more intriguing. What if fast radio bursts aren't natural at all? What if they're engineered? Harvard astronomer Avi Loeb has suggested that fast radio bursts could be the exhaust signatures of alien spacecraft using massive light sails for interstellar travel. The energy requirements match perfectly with theoretical propulsion systems that could accelerate spacecraft to significant fractions of light speed. If Loeb is correct, we're not just detecting alien signals, we're watching alien civilizations travel between the stars. But this raises an even more disturbing question. If aliens possess technology advanced enough for routine interstellar travel, why haven't they visited us? The answer might lie in our own cosmic neighborhood. In 2017, astronomers discovered Oumuamua, the first confirmed interstellar object to enter our solar system. Oumuamua was unlike anything we'd ever seen. Elongated like a cigar, tumbling through space, reflecting sunlight in ways that suggested a highly polished metallic surface. But here's what made Oumuamua truly bizarre. As it moved away from the sun, it accelerated. Not from gravitational forces, which we can calculate precisely, but from some unknown non-gravitational force. Natural objects don't behave this way. Comets can accelerate when ice vaporizes and creates thrust, but Oumuamua showed no signs of outgassing, no comet tail, no evidence of ice or organic compounds. Avi Loeb published a paper suggesting that Oumuamua might be artificial, a light sail perhaps, or the fragment of alien technology. The scientific community reacted with skepticism, but no one has provided a satisfactory natural explanation for Oumuamua's acceleration. Was it really humanity's first contact with alien technology? A probe sent to study our solar system? Or something even more extraordinary? The object is now beyond our ability to study further, leaving us with more questions than answers. These mysteries multiply when we examine our own planet's history. Earth has experienced 5 major mass extinction events, catastrophes so severe they eliminated most life on the planet. The most recent, the extinction that killed the dinosaurs 66 million years ago, resulted from an asteroid impact that released energy equivalent to billions of nuclear weapons. But here's what's truly unsettling. The timing of these extinction events shows patterns that suggest they might not be random. Paleontologists have identified what appears to be a 26 million year cycle in extinction events. Natural astronomical cycles don't operate on such precise timescales. What force could be driving mass extinctions with such regularity? One hypothesis suggests that our solar system's movement through the galaxy exposes Earth to periodic dangers. As we orbit the galactic center, we pass through spiral arms where asteroid impacts and cosmic radiation increase dramatically. These galactic cycles could explain the periodic nature of mass extinctions. But some researchers propose a more disturbing alternative. What if the extinction events aren't natural at all? What if they represent something far more systematic and deliberate? The geological record preserves evidence of every major event in Earth's history. Asteroid impacts leave iridium signatures in rock layers. Volcanic eruptions create distinctive chemical markers. Ice ages alter atmospheric composition in measurable ways, but some extinction events show signatures that don't match any known natural phenomenon. The Permian-Triassic extinction 252 million years ago eliminated 96% of marine species and 70% of terrestrial life. This event, known as the Great Dying, shows chemical signatures suggesting the rapid release of enormous quantities of greenhouse gases. The scale and speed of this atmospheric change exceeds what any known natural process could produce. Recent analysis of the extinction boundary reveals isotope ratios that match exactly what we'd expect from massive industrial activity. Carbon signatures identical to burning fossil fuels on a planetary scale. Sulfur compounds consistent with large-scale chemical manufacturing. These signatures could result from massive volcanic eruptions or methane releases from warming oceans. But the precision and coordination of the chemical changes suggests something more systematic. What if the Great Dying wasn't natural? What if it was engineered? This possibility becomes more disturbing when we examine the patterns of life that emerged after major extinction events. Mass extinctions consistently clear ecological niches that are then filled by entirely new forms of life. The extinction that killed the dinosaurs allowed mammals to diversify and eventually produce human intelligence. Earlier extinctions enabled the rise of complex life forms that wouldn't have evolved in the presence of dominant species. Each extinction event seems precisely calibrated to promote evolutionary advancement while eliminating species that might have prevented further development. The fossil record shows that evolution proceeds in sudden bursts rather than gradual change. The Cambrian explosion, 540 million years ago, saw complex life forms appearing almost instantly in geological terms. Eyes, shells, sophisticated body plans emerged simultaneously across multiple species without apparent evolutionary intermediates. Traditional explanations invoke preservation bias and environmental changes, but the timing and coordination of these evolutionary leaps suggests something more systematic might be involved. What if Earth's evolutionary history has been guided? What if mass extinctions and evolutionary bursts represent interventions by intelligence operating on timescales we can barely comprehend? The idea sounds like science fiction, but the evidence in our geological record tells a story that's difficult to explain through random natural processes alone. The precision, timing, and outcomes of major evolutionary events show patterns that suggest coordination by forces beyond our current understanding. This possibility gains credibility when we consider the scale of time involved in galactic evolution. Our galaxy has existed for over 13 billion years. If intelligent life emerged anywhere in the galaxy, even 1 billion years ago, they would have had enough time to spread throughout every star system, including ours. They would possess technology so advanced that their activities might be indistinguishable from natural phenomena. They could engineer entire ecosystems, guide planetary evolution, even manage the development of younger species like humanity. But if advanced aliens have been active in our galaxy for billions of years, why don't we see obvious signs of their presence? The answer might be that we're looking for the wrong things. We expect alien technology to resemble human technology, but civilizations millions of years older than us might have developed approaches to engineering that work entirely through natural processes. Their technology might be so sophisticated that it operates through the fundamental forces of physics rather than crude mechanical systems. Consider how advanced aliens might approach the challenge of managing a galaxy containing billions of potentially habitable worlds. They wouldn't need to build obvious megastructures or emit detectable radio signals. Instead, they might develop technologies that work through gravitational fields, quantum effects, or biological systems that appear completely natural to developing civilizations like ours. They could manage entire ecosystems, guide evolution, even influence planetary climate through methods that leave no obvious technological signatures. This hidden presence theory could explain the Fermi paradox. We don't detect alien civilizations because they don't want to be detected. They operate through technologies so advanced that their activities appear as natural phenomena. They might be all around us, managing galactic evolution through invisible systems that have operated for millions of years. We could be living in a carefully managed cosmic preserve, our development guided by intelligence that remains hidden until we reach sufficient technological maturity. Recent discoveries in astrobiology support the possibility that life might be far more common than we previously believed. NASA's Kepler Space Telescope has confirmed thousands of exoplanets, many in the habitable zones of their stars. The James Webb Space Telescope has detected water vapor and organic molecules in the atmospheres of distant worlds. Every discovery suggests that the basic ingredients for life exist throughout the galaxy. If life is common, intelligence should be common too. Yet we still find no obvious signs of alien civilizations. The silence might be temporary. SETI researchers are developing new detection methods that could reveal alien technologies we currently can't recognize. Machine learning algorithms are analyzing vast databases of astronomical observations, searching for patterns that human researchers might miss. Quantum communication systems might allow us to detect alien signals transmitted using technologies we're only beginning to understand. We might be on the verge of discoveries that will revolutionize our understanding of intelligence in the universe. But there's another possibility that few scientists want to discuss openly. What if the reason we don't detect alien civilizations is because they don't survive long enough to become detectable? What if intelligence itself contains the seeds of its own destruction? Every technological civilization might follow a similar developmental path that leads inevitably to self-destruction before they can expand beyond their home worlds. We might be living through the same dangerous transition that has eliminated countless alien civilizations throughout galactic history. The evidence for this dark possibility surrounds us. Human civilization has developed the capability to destroy itself through nuclear weapons, climate change, biological warfare, or artificial intelligence systems that could escape human control. We're approaching technological capabilities that could either ensure our survival for millions of years or guarantee our extinction within decades. The choices we make in the next century will will determine whether humanity joins the galactic community or becomes another silent world in the cosmic graveyard. Climate research reveals that Earth's atmosphere has undergone dramatic changes throughout geological history. Some of these changes correlate with mass extinction events, suggesting that atmospheric manipulation might be a common cause of civilizational collapse. Any industrial civilization will inevitably alter its planet's atmospheric composition through energy production and manufacturing. If they don't develop sustainable technologies quickly enough, they create runaway climate changes that make their worlds uninhabitable. Nuclear archaeology provides another disturbing parallel. Every technologically advanced civilization will likely discover nuclear energy and nuclear weapons. The same technologies that could provide clean energy for millions of years also enable weapons capable of destroying entire civilizations. The window between developing nuclear technology and learning to control it safely might be narrower than most civilizations can navigate successfully. Our own species came close to nuclear war multiple times during the Cold War. We might have been extraordinarily lucky to survive our nuclear adolescence. Artificial intelligence research suggests another potential great filter. Any civilization that develops sufficiently advanced AI faces the possibility that their creations could become autonomous and decide that their creators are unnecessary or even harmful. The transition from human-controlled AI to artificial general intelligence represents a critical threshold that could either elevate civilization to unprecedented heights or terminate it entirely. We're approaching this threshold now with little understanding of how to navigate it safely. Biological research reveals additional existential risks. Genetic engineering technologies could enable the creation of pathogens designed to target specific populations or entire species. Biotechnology that could eliminate genetic diseases and extend human lifespan could also be weaponized to create biological agents more dangerous than any natural plague. The same knowledge that promises to defeat aging and disease also enables the creation of extinction-level biological weapons. The combination of these existential risks creates what researchers call the Great Filter, a developmental stage that eliminates most technological civilizations before they can expand beyond their home worlds. The Great Filter might explain why the galaxy appears empty despite the billions of potentially habitable worlds. Most civilizations might destroy themselves during the critical transition from planetary to interstellar species. But human civilization also shows unique characteristics that might allow us to survive where others failed. Our global communication networks enable unprecedented coordination and information sharing. International cooperation frameworks, despite their imperfections, provide mechanisms for addressing planetary-scale challenges. Our growing awareness of existential risks allows us to identify and potentially mitigate dangers before they become terminal threats. We might represent the first civilization in our region of the galaxy to successfully navigate the Great Filter. The search for extraterrestrial intelligence has evolved beyond simple radio astronomy. Modern SETI programs search for techno-signatures, artificial modifications to planetary or stellar environments that would indicate the presence of advanced civilizations. These might include atmospheric pollutants from industrial activity, artificial lighting patterns on planetary night sides, or massive engineering projects that alter the emission spectra of entire star systems. As our detection capabilities improve, we might discover evidence of alien civilizations that use technologies completely different from our current approaches. Breakthrough. Listen, the most comprehensive SETI program ever undertaken has analyzed millions of stars and found no confirmed artificial signals. But the program has only examined a tiny fraction of the galaxy and only for very specific types of signals that resemble human technology. More advanced civilizations might communicate using quantum entanglement, gravitational waves, or other phenomena that we're only beginning to understand. They might encode messages in cosmic ray patterns, asteroid orbits, or the genetic sequences of life forms they've engineered and distributed throughout the galaxy. The recent discovery of interstellar objects like Oumuamua suggests that artificial artifacts might regularly pass through our solar system. Most would be too small or moving too quickly for us to detect with current technology, but improved space-based telescopes and faster response systems might allow us to identify and study artificial objects before they disappear back into interstellar space. Each interstellar visitor might carry information about its creators or serve as a probe designed to study developing civilizations like ours. Astrobiological research continues to push the boundaries of where and how life might exist. Scientists have discovered extremophile organisms living in environments previously thought impossible for life. Deep ocean hydrothermal vents, highly radioactive zones, extremely acidic or alkaline conditions, temperatures approaching the boiling point of water. If life can exist in such extreme environments on Earth, it might be possible in places throughout the solar system we never considered habitable. Jupiter's moon Europa, Saturn's moon Enceladus, even Venus's upper atmosphere might harbor microbial life forms adapted to conditions that would instantly kill terrestrial organisms. The discovery of life anywhere beyond Earth, even simple microbial life, would revolutionize our understanding of biology and intelligence in the universe. It would prove that life emerges naturally under a wide range of conditions, suggesting that intelligence might be equally common. But it would also intensify the Fermi paradox. If life is common, where is everybody? Why don't we see obvious signs of intelligence that should have emerged millions of years before us? Quantum mechanics might provide part of the answer. Recent experiments with quantum entanglement and quantum information theory suggest that advanced civilizations might develop communication and transportation technologies that operate entirely outside our current understanding of physics. Quantum teleportation, though currently limited to simple particles, might eventually enable instantaneous transportation of complex objects or even consciousness across vast distances. Quantum communication networks might allow real-time coordination between civilizations separated by thousands of light years. If advanced aliens have mastered quantum technologies, they might be operating all around us in ways that remain completely invisible to our current detection methods. They could be communicating, traveling, and coordinating activities using quantum channels that leave no trace in the electromagnetic spectrum we monitor. We might be like Stone Age humans trying to detect radio signals, lacking the technological foundation even to recognize what we're missing. The implications extend beyond simple communication. Quantum field theory suggests that sufficiently advanced civilizations might be able to manipulate the fundamental structure of space-time itself. They could create pocket dimensions, stabilize wormholes, or even adjust the laws of physics within limited regions of space. Such capabilities would allow them to exist alongside developing civilizations like ours, while remaining completely undetectable until we develop the scientific understanding necessary to recognize their presence. Recent breakthroughs in consciousness research suggest another possibility that challenges our assumptions about intelligence and civilization. If consciousness represents a fundamental property of the universe, rather than an emergent property of complex brains, then intelligence might exist in forms we've never imagined. Quantum consciousness theories propose that awareness might operate through quantum field effects that pervade all matter and energy. Advanced civilizations might have learned to interface directly with these quantum consciousness fields, achieving forms of existence that transcend biological limitations entirely. Such quantum consciousness entities might be present throughout the galaxy, existing as distributed patterns in the quantum vacuum itself. They would be immortal, capable of thinking on cosmic timescales, and able to influence physical processes through direct manipulation of quantum fields. To such beings, biological civilizations like ours might appear as brief flickers of activity, interesting but temporary phenomena in the larger tapestry of cosmic consciousness. The possibility of quantum consciousness civilizations would explain the Fermi paradox completely. We don't detect alien civilizations because they've transcended the need for detectable technology. They exist as pure consciousness operating through the fundamental structure of reality itself. They might be watching us, studying us, even guiding our development through subtle influences on quantum processes that appear as random events to our current level of understanding. But the most profound possibility is that we're not actually alone at all. The silence might be an illusion created by our limited perspective and primitive detection methods. Advanced civilizations might be present throughout the galaxy, operating through technologies and forms of existence so sophisticated that they remain invisible to developing species like ourselves. The universe might be teeming with intelligence operating on scales and through methods that we won't recognize until we achieve similar levels of advancement. The search for extraterrestrial intelligence might be approaching a revolutionary threshold. As our understanding of quantum mechanics, consciousness, and the fundamental nature of reality expands, we might develop detection methods capable of recognizing forms of intelligence that currently remain hidden. The James Webb Space Telescope is already detecting atmospheric compositions on exoplanets that could indicate biological or even technological activity. Machine learning systems are identifying patterns in astronomical data that human researchers never noticed. Quantum communication experiments might eventually detect artificial quantum signals from alien civilizations using technologies we're only beginning to develop. Within the next few decades, we might answer the most profound question in all of science. Are we alone? The answer might be more complex and more amazing than we ever imagined. We might discover that intelligence is not only common in the universe, but that it exists in forms so advanced and so different from our current understanding that we're only beginning to develop the conceptual frameworks necessary to recognize its presence. The journey to answer this question will transform human civilization itself. The technologies we develop to search for alien intelligence will inevitably lead to breakthroughs in quantum computing, consciousness research, and our understanding of the fundamental nature of reality. Whether we find aliens or not, the search will expand human knowledge and capabilities in ways that ensure our species' long-term survival and development. The silence might be ending soon. The signals might be there, waiting for us to develop the wisdom and technology necessary to recognize them. The universe might be about to reveal that we've never been alone at all. We've simply been waiting for the moment when we're ready to join the galactic community that has existed around us all along. The next breakthrough could happen tomorrow, next year, or next decade. But when it comes, it will change everything we thought we knew about our place in the cosmos. Are we alone? The answer may be closer than we think, and when we do, humanity will take its first steps into a universe far stranger, far more wondrous, and far more populous than we could ever have imagined. The silence is about to be broken. The cosmic conversation is about to begin. Subscribe to Quantum Universe, because at our next gathering, we'll unveil the latest discovery that could finally answer whether we're truly alone in this vast, mysterious cosmos.